Okay, we're on.
Okay, greetings, South High Packers. Welcome back to another Algebra 3-4 with Mrs. Kuhlman and Mama Heine. And we are continuing on with our discussion of exponential functions, growth versus decay. This is part 2. Let's go ahead and talk about, I'm going to just uncover this right here. And I want you guys to pause this, and I want you to write this couple of sentences down in your notes. It says that we can predict whether an exponential function will be growth or decay without actually graphing the function. We focus on the base, which is going to be our letter B. So here's our important equation that you need to get down. Y equals A times B to the x power. Notice that x is an exponent. This letter B right here, it's going to be a number. It could either be a whole number or it could be a fraction. If B is a whole number, it's an example of growth. But if B is a fraction, it will be an example of decay. Okay, and exactly what I just said is stated here in written form. If B is greater than 1, meaning it's a whole number, 1, 2, 3, 4, 5, 6, then it's exponential growth. If B is between 0 and 1, that's any fraction, like 1/2, 1/3, 1/4, those fractions are in between 0 and 1, then we have an example of exponential decay. Now, let's take a look at the A. We already talked about B. Let's look at that letter A. If A is greater than 1 whole, if it's 2, 3, 4, 5, then the graph is called a stretch. If A is between 0 and 1, again, if A is a fraction, 1/2, 1/3, 1/4, then the graph is called a compression. And if A is less than 0, meaning if A is a negative number, -1, -2, -3, -4, so forth, then the graph is called a reflection, and it flips over that x-axis. And you'll see examples here in a second. Okay, we're going to go ahead and flip these notes over, and I'm going to talk about some graphs. Thank you. Okay, let's take a look at this first graph. Y equals 2 to the x. Notice that x is an exponent, and I just want you to look at it and notice that there are 5 points. Point 1, 2, 3, 4, 5. Notice this middle point is right on that y-axis. It's called the y-intercept. And notice it's slowly increasing from this point to this point to this point. It's steadily increasing, but then it takes a sharp exponential growth and it explodes and it goes really quick up and very fast. And that's an example of the coronavirus. Okay, let's go to the next graph. That next graph, notice we have an extra number out front, this 2. This graph over here, there was not a number out front. There was no A value. This is just my B value. That 2 is my B value. But over here, I have an A value and a B value. This B value indicates it's a whole number, so it indicates it's a growth. And this 2, this A, is greater than 1, so it's a stretch. And if you can notice the difference between these two graphs, this second graph, it's like taking a rubber band and stretching it. It becomes longer and thinner. So we call it a stretch. Okay, let's look at the third graph. This third graph down here is called a compression. Notice that A value is a fraction now. This graph becomes short and fat. It's like when you compress someone, you're giving somebody CPR and you compress on their lungs. Their lungs are inhaling with oxygen and your lungs are getting fat and more full. So this graph is getting fatter, it's getting wider. Okay, and that's because of that fraction. That fraction indicates a fat graph. This whole number up here, that 2, that whole number, indicates a tall, skinny graph. Finally, our last graph is called a reflection. And I want you to notice that this graph is below the x-axis. It did a flip over that x-axis. And what tells me that it's a reflection is that negative number right there, -2. This a value is negative. It means reflection. It gets flipped over that x-axis. All right, South High Packers, that's all for today. More next time. I hope you guys have a great afternoon. Go Packers.